Okay, so I want to do the solution for today's in-class problem in which we found the total force on the charge in the bottom left-hand side of this equilateral triangle. So let's number these, Q1, Q2, and Q3, so we know what we're referring to. Okay, and then I'm going to remember our rules are first draw the arrows, and then find the forces, and then find the components, and then add them. All right, so if I draw the arrows, we've got the force between 1 and 2 is repulsive because they're both positive, and it goes along the line joining them. So what I usually do is I imagine I have a nail going through charge 1 and charge 3, and I just want to find what direction would Q1 move due to the forces of the other two. So Q2 and Q1 are positive, so it's repulsive. So Q1 is going to get pushed directly away from Q2. So this is going to be F12. Okay, the direction of the force between Q3 and Q1 is also going to be repulsive, also along the direction between them. So this is my F13. And the sum of those two will be addition of those two vectors. So it's going to go somewhere in between them. So it's called the F total. All right, so now I need to find the magnitude. So the magnitude equation, remember, is force Coulomb's law K, Q1, Q2 over R squared. And I always put in just the absolute value of the two charges so that I don't get mixed up about whether the force is in the positive or negative direction. I'm just going to find the length of the vector, and then I'll worry about the directions when I find the components. All right, so let's do it for force between 1 and 2. So K is 9 times 10 to the 9. Q1 is 2 nanocoulombs. So 2 times 10 to the minus 9 coulombs. Q2 is 2 times 10 to the minus 9 coulombs. Because these guys are positive, I didn't have to flip their signs. And then the denominator, I'm going to have the distance between those two charges. So R12 is the distance along the length of the bottom. So R12 is 1 centimeter. And I need to put that into the correct SI unit. So I convert that to meters, 0.01 meters. And if I do that, I get 3.6 times 10 to the minus 4 newtons. All right, how about F13? Same thing, except now I'm going to do Q1, Q3. So it's going to be K, Q1, Q3 over the distance between 1 and 3 squared. So 1 is still 2 nanocoulombs. 3 is 1 nanocoulomb. And R13, it's an equilateral triangle, so R13 is the same as R12, 1 centimeter, 0.01 meter. And I get 1.8 times 10 to the minus 4 newtons. Okay, so I've drawn the forces, I found the magnitudes. Now I need to find the vectors and their components. So what I like to do always when I add vectors is to make myself a little table, a little chart where I put X and Y, and I break each vector into components. So let's do F12 and F13 in components. So if I look at F12, that's the one that's just going directly over to the left. So that one has only an X component. It has no vertical component, so no Y component. So I can go straight away and put in a 0 for the Y component. And what's the X component? Well, the X component is going to be the total length of the vector. So that's 3.6 times 10 to the minus 4 newtons. And because it's going in the minus X direction, it's going to the left, I'm going to put a minus sign in front. So this is where I put in the direction of the force. All right, how about the vector that's going down in this direction, force 1, 3. So if I look at that, that's in quadrant 3, right? If I have my triangle, I've got quadrant 1, 2, and 3. So it's going in that direction, so it's going to have a negative X component and a negative Y component. So let me go ahead, I can put a minus sign in front of both of them right away. And you can see that it's going partly to the left and partly down, so we are going to have to break that vector into components. So let me go ahead and draw a picture of what's going on. So here's the vector. I know its length. Its length is 1.8 times 10 to the minus 4. And I need to find the directions. And so I need to know find the components, so I need to know what the angles are. So remember, what I have here is an equilateral triangle. So I've got 60 degrees, 60 degrees, and 60 degrees. They're all equal angles, add up to 180. So what I know is that the angle here is 60. So this angle here also has to be 60 degrees. So if I want to find the components of it, then I'm going to have to break it into x and y components. So the y component is the vertical side, the x component is the horizontal side of this right angle triangle. And so if I look, here's my angle, the x component side, so this is F13x, that's the horizontal side, this is F13y is the vertical side. And then I say, okay, so what is the y component? The y component is opposite, so opposite is going to be the sine. The x component is adjacent, which means it's touching, so that's going to be the cosine. All right, so now I just put in the magnitude, 1.8 times 10 to the minus 4 cosine of 60. And the y is going to be 1.8 times 10 to the minus 4 sine of 60. And if I put that in my calculator, and I need to make sure that I do that in the correct units, I get for my y component 1.56 times 10 to the minus 4 newtons, and that's negative. And if I do it for my x component, I get minus 9 times 10 to the minus 5 newtons. Okay, so now I want to find the total. So let me scroll this down so I can get there. So F total in the x direction, to get that, what I do is I just add up down my column. So let me put these in brackets so you know that's the result. So my F total in the x direction is minus 3.6 times 10 to the minus 4 minus 9 times 10 to the minus 5. And so I get minus 4.5 times 10 to the minus 4 newtons. In the y direction, I'm going to add up down my y column, so I got 0 minus 1.56 times 10 to the minus 4 newtons. So that's just as minus 1.56 times 10 to the minus 4 newtons. So what does my total look like? Let me draw a new coordinate system. So I'm going to go 4.5 back in the x direction. So I'm going to go this way, minus 4.5. Then I'm going to go down minus 1.5. So it's going to be something like this. So there is my F total vector. And that's what we expected from our picture. We expected it to be somewhere in between those two force vectors. All right, so what we're always asked is find the magnitude and find the direction. So the magnitude of that vector, that's easy. You just use Pythagoras' theorem, right? So F total is the square root of F total x squared plus F total y squared. So that's the square root of minus 4.5 times 10 to the minus 4 squared plus minus 1.56 times 10 to the minus 4 squared. Okay, be careful. Some of your calculators, scientific calculators, when you put the minus and you square it, for some reason it doesn't square the minus sign and it gives you a minus sign. You know that if you square a negative number, you always get a positive number. All right, so let's put our numbers in. I get F total is a positive number, 4.76 times 10 to the minus 4 newtons. Okay, and what's the direction? Well, to get the direction, I know my x component, 4.5 times 10 to the minus 4. I know my y component, 1.56 times 10 to the minus 4. And I need to find the angle. So to find the angle, what we do is we take the tangent. So tangent is x over y. So tan theta is x, sorry, is y over x, sorry. So tan theta is opposite over adjacent, so minus 1.56 times 10 to the minus 4 over minus 4.5 times 10 to the minus 4, which gives us 0.347. So to get theta, theta is going to be the inverse tan of 0.347. And again, always make sure your calculator's in degrees before you start. So take sine of 30. If your calculator doesn't give you 1/2, then you know it's wrong. All right, so your calculator is going to pop out a number of 19.1. So if you put in the number 19.1 on your test, or if you put it in on your homework server, it's going to tell you it's wrong. Why is it wrong? Well, that 19.1, that's the angle inside the triangle. But you need to give an angle relative to the plus x direction. So usually what we do is we say, okay, so if we go counterclockwise, that's a positive number. So we go 90, 180. So it's going to be 180 plus 19.1. Okay, so that would be an angle of 199.1 degrees from the plus x. And on the homework service, what it asks you to do is do a number between 0 and plus 180 if it's in quadrant 1 or 2, or between 0 and minus 180 if it's in quadrant 3 or quadrant 4. All right, so the number that you'd have to give on your Mastering Pearson homework, you'd do, this is minus 90, and then we need to do minus whatever this angle is in here. If I do 180 minus 19.1, I get 160.9. So that tells me this angle here is 160.9 degrees. So on Pearson, you'd say the angle, the direction is minus 160.9 degrees from the plus x-axis. So this last step of figuring out where that angle actually is, so your calculator gives you a number, but you need to draw the picture to find it out. That last step is very important. Make sure you practice doing multiple problems of these, because there will be a problem like this on the first test.